Alright, so in this video, we're going to look at combined transformations. And this is going to be the last topic for this chapter. Alright, so basically the idea is that you're starting with a known graph, f of x, and this is being transformed by, as say, k f of bx minus a plus c. Something like this. So this represents all the transformations we have talked about. We have a vertical stretch, a horizontal stretch, a horizontal translation, and a vertical translation. So this is how I like to look at graph transformations. One, if you have all of these combined transformations, then I like to start with horizontal transformations. I like to work from inside out. Inside out. So first, I will translate horizontally by the vector a comma 0, right? Because x minus a. So I'll just translate it horizontally, and then I will stretch. So a horizontal stretch, right? Parallel to the x-axis by a factor. So if you have bx, then the factor is going to be 1 over b with an invariant y-axis. And then I'm going to perform the vertical stretch. It's parallel to the y-axis by a factor of k with an invariant x-axis, and finally you're going to perform a vertical translation by the vector 0 comma c. So this is the order I like to follow. I start with a horizontal translation, then do a horizontal stretch, then do a vertical stretch, then do a vertical translation. And usually this should correctly transform your graph of f of x to this expression. All right. So let's do some questions related to transformations. So this is a graph of g of x. So I've just drawn it again on a bigger grid. And we're going to be doing these transformations. And I'm going to do one, and then I'm going to erase it so that I have space to do the other one. All right. So remember the order. 1, we're going to do a horizontal translation. Then number 2 is going to be the horizontal stretch. And we'll do reflections with the same priority as stretches. And number 3 is going to be the vertical stretch or the vertical reflection. Oftentimes we'll do these operations together sometimes as well. Stretch. And finally we have vertical shift or vertical translation. Alright, so now that we have these order done, here we have a horizontal translation and we have a vertical translation. So we don't have shifts involved. So if it's just two translation operations combined together, we can actually do it together. So we can, instead of translating first, so we have a horizontal translation by -2, 0 vector, right? -2 comma 0. And then we have a vertical shift by 0 comma 3. So we can combine the two translation vectors as -2 over 3. -2 shift left by -2 units, shift up by +3 units. So we can do this together. All right, so I'm erasing the priority. I'm going to just say it verbally. And your overall translation vector for A is going to be -2 comma 3. And let's look at that. So 2 units to the left. So basically -2 means take your x coordinate, move 2 units to the left. +2 would be this direction, right? So 2 units to the left, 3 units up. -2 plus 3. So we're going to do that. 2 units to the left, 1, 2, 3. Every point on the graph. So I have 1, 2, 3, 4, 5 points, right? 1, 2 units to the left, 1, 2, 3 units up. 1, 2 units to the left, 1, 2, 3 units up. 1, 2, 1, 2, 3 units up. 2 units to the left, 3 units up. And I can join my points together. So the shape of the graph is not going to change. So that is the solution for A. All right. For B, so I'm going to erase this. I hope you can see the answer here. All right. For B, I have a vertical stretch. I need to do my vertical stretch and reflection first, and then do my vertical shift. So let's do the stretch. I'm going to do the stretch in orange. So g of x, remember, g of x, if your x is input, g of x is your output. G of x is going to be your y coordinates. I need to 2 times my y coordinate, right? 2 times my output, and then I need to plus 1. So let's do the shift first. 2 times my output. My output is 1. I need to multiply by 2. My output is minus 2 here. I need to multiply. Output is minus 2. I need to multiply by 2. That gives me minus 4. Output is minus 1. Multiply by 2, minus 2. Output is 0 times 2 is 0. Output is 1 minus times 2 is positive 2. So I get my orange points. And now I need to add 1, right? Shift up by 1. So my final answer is going to be my points in red. All the points in orange shifted 1 unit up. So 2g of x gives me the orange points. And then by adding 1 to the orange points, I get my red point. All right. So my final solution is going to be my points in red. And now let me just erase my reference orange points. All right. So the curve is going to look something like this. All right. And we are done with B. C, instead of writing it as 2 minus g of x, I can write it as minus g of x plus 2. And we can see that we have a vertical reflection and we have a vertical shift. So we are going to do that. Let me erase this. So a vertical reflection basically means whatever output values I have, I'm going to flip the sign, right? If I have my output is positive 1, I'm going to multiply by negative 1, minus, right? Basically multiply by the negative sign, and I'm going to get minus 1. If I have minus 2, if I multiply by minus 1, or just multiply by the minus sign, I get plus 2. Minus 1, multiply by the minus sign, I get plus 1. 0 multiplied by the minus sign is still 0. Positive 1 multiplied by the minus sign, I get negative 1. I get the points in green, and then I need to add 2 units. So I need to vertical shift by 2 units, so I get my red curve at the end, right? So I just shift vertically by 2 units. I get this point, 1, 2 shift, 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 I get this point. And now I'll just erase my green points because I drew them for reference. And finally, I have this. All right. So that is going to be my solution. So some coordinates would be negative 2, 1, minus 1, 4, 0, 3, 1, 2, and then 2, 1. All right. So that is your solution for C. For D, I have a horizontal reflection. So so minus x means a reflection about a y-axis, right? And then I have a vertical stretch and I have a vertical shift. So we're going to start with the horizontal stretch, or basically the reflection about the y-axis first. So g of minus x, if I reflect, basically that means I keep my y coordinates the same. I switch the sign of my x coordinate, right? Minus x, that is what it means. If I put plus 3, it's going to go to minus 3. So whatever g of 3 is, now it's going to be g of minus 3. And whatever g of minus 3 is, it's going to be g of plus 3. So I just need to flip my x coordinates. So I have minus 2. You keep the same output value, but your input value changes to plus 2. So this point, 1. So this is minus 1. This point flips over here. This is on the axis, it doesn't change. This flips over here. And this point flips over here, right? So we have sort of the green curve. If you flip your blue curve over the y-axis, you get your green curve. And now you need to vertically stretch it by 2. So a vertical stretch by 2 So you multiply your output values of your green curve, not your blue curve now. Your green curve by 2. So I get plus 2, 0 stays 0, right? Output 0 will stay 0. Minus 2 times 2 is minus 4. I have minus 1, changes to minus 2. And then 1 times 2 is 2. So I have my orange points. Alright, and now finally I have the red points, which is plus 1. So 3, so I just shift my orange points by 1 unit up, right? Okay. So minus 4, 1 unit up is here. And then finally 2, 1 unit up is here. And now let me just erase my other points so that I can connect to my red dots. Okay, I don't know what happened. Okay, sorry. So now let me just join my red dots. And I get this. Alright, so that should be your final answer for D. Yeah, looks correct. Alright. Part E, I have a vertical stretch and reflection, and then I have a vertical translation. So I can do those together actually. So if I just multiply by minus 2 of my output values, it's going to take care of the reflection as well. So 1 times minus 2 maps to negative 2, right? Minus 2 times minus 2 maps to positive 4. 0 maps to 0. That's no surprise. Minus 1 times minus 2 maps to positive 2. And 1 times minus 2 maps here. And then I need to shift by minus 1 unit. So I need to shift 1 unit down. So if I shift 1 unit down, the green points, I get my red points, right? And now I can erase my green points. Alright, so now my final answer is going to look something like this. Alright. So minus 1 comma 3, minus 2 comma minus 3, 0 comma 1, 1 comma minus 1, and 2 comma minus 3. There's some points on the graph. Alright, we're done with E. Now we have a horizontal so we have a horizontal stretch first and then a vertical shift. We want to follow the priority. So let's do the horizontal stretch first. So this means I multiply my x coordinates by the factor 1 over a, b 1 over b, right? And b is 2 in this case, if this is b. So 1 over 2. So I need to multiply with an invariant y-axis. That means I don't change my output values. I don't change my values on the y-axis, but I multiply my values on the x-axis by half. So minus 2 comma 1 will become minus 1 comma 1. Minus 1 comma minus 2 will become minus half comma minus 2. 0 does not, it's just 0, right? 1 comma 0 will be half comma 0. 2 comma 1 will be 1 comma 1. So I have my orange curve. Sorry about that. Okay. And I need to add 3. So I need to add 3 to my final points. So so this is at 1. I'm so sorry, it shifted a bit. But when I shift 3 units up, so 1, 2, 3 units up, 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 and I erase the orange curve. Then my curve will look something like this. So I know the graph moved a bit, so the points did not look accurate because I moved it with my hand. So basically what happens on the iPad is that like I have this image in the background and then I'm drawing my dots on top. So if the image in the background moves, the dots don't move. So the dots stay where they are. So that's why the graph shifted a bit. But if you do it correctly, so if you do it on paper, okay, this doesn't work. Wait, let me just do this. Okay, this is what it's going to look like. So you have 0.5 comma 1, 1 comma 4, 1 comma, minus 1 comma 4, 1 comma 4, 2, 0 comma 2, and then 0.5 comma 3. So that is how your graph is going to look like. All right. So we have this. This is interesting. So now let me show you something. I can write this expression as this, or I can write it as g 2x minus 3, right? This is the same expression. If I write it in this way, the first way, I need to do my horizontal shift first. All right, so if you write it in the first way, you want to do your horizontal, sorry, I paused the video for a while. You want to do your horizontal translation first, and then your horizontal stretch. If you write it this way, you want to do your stretch first, and then your horizontal translation. So I prefer to do it the first way. I prefer to shift first. I prefer to do the translation first and then do the stretch. All right, so I stretch, minus 6 means by the vector 6 comma 0, right? So I shift everything 6 units to the right. Okay, the 2 plus 6, this point is gonna here, minus 2 plus 6, this point is gonna go here, 0, 6, this point is gonna be here, minus 6 plus 7, this point is gonna be here. No, sorry, my bad. Okay, minus 1 plus 6, 5. Okay, this is gonna be here. Okay, so my graph looks something like this. And then I need to do the horizontal stretch by a factor of half, right? So by a factor of half, I keep my y-axis invariant, but I need to halve all my x-axis value. Okay, so 4 comma 1 becomes 2 comma 1. 5 comma minus 2 becomes 2.5 comma minus 2. 6 comma 1 becomes 3 comma 1, and then so I shifted 3 points. Okay, this is also a point, by the way. 7 comma 0. 7 comma 0 becomes 3.5 comma 0, and then 8 comma 1 becomes 4 comma 1. So let me just erase the green line. Okay. And now finally, we want to, okay, that's it. It's actually, there's no more operation. So our final solution, let me do it in red. It's gonna look something like this. Okay. Sorry, not here. This point is here, this point is here. My bad. Something like this. All right. So that should be your answer. And you can try to do it the other way as well. So I believe this is the solution to G, right? Yeah. So you can do it in the other order as well, but yeah, this should be your answer. And so you can try doing the stretch first and then the shift. You should get the same answer. All right, and H. So first, I can do the shift, and then I can do the stretch. So that's the order I'm going to do. I'm going to do the shift first. So plus 1 means I shift by the vector minus 1 comma 0. So if I shift by the vector minus 1 comma 0, I get the orange curve. And then if I do the minus x part, this is just to flip over the y-axis. So if I flip these points over the y-axis, all right, so we've done the shift left by 1, and now we need to reflect. Sorry, I pressed pause again. That's why the audio might have cut abruptly. So now we've shifted by 1 unit to the left. We want to flip over the y-axis. So we want to reflect over the y-axis. So our x coordinates are going to change signs. The y output values will not change. So this point when I reflect it, I get the red point. This point when I reflect it, I get this point. This point when I reflect it, I get this point. This point when I reflect it, I get this point. So my final answer, so let me just erase the orange line, is going to look, okay, I missed 1 point. Let me think. My bad. Okay. I missed 1. Okay, this point. All right. So your final solution should look something like this. Yeah. All right. And that is it. That is it for question 1. It took a long time. All right, let's move on to question 2. The diagram shows the graph of y is equal to f of x. Write down in terms of f the equation of the graph of each of the following diagrams. So let's see. So obviously, we have a long part here and a short part here. The long part and the short part, they have switched sides. So there is some f of minus x involvement. There is a flip over the y-axis, right? So you have something flipped over the y-axis that is going to give you the red graph. So let me just draw it. If you flip the graph over the y-axis, you're going to get the red graph, right? And basically the graph we have here is the red graph that I have drawn here, shift multiplied by 2, right? Because all the output values have been multiplied by 2. So A is going to be this. So you flip over the y-axis and you multiply your output values by 2. So it's going to be 2 f of minus x. And you just have to sort of check how your output values have changed. Okay. So this one, if you think about it, right? So let me erase this one. So if you think about it, this one involves a reflection over the x-axis. Yeah, a reflection over the x-axis. So let's consider minus f of x. Right? Minus f of x is going to give you the red curve. So something like this. So the red curve is going to give you minus f of x, and it's minus f of x, but it's shifted 3 units up, or 2 units up, right? So it's going to be minus f of x, and then it's shifted 2 units up, so plus 2. So you can write it as 2 minus f of x. That is also okay. So we're done with B. And for C, I'm so sorry. Okay, and for C. Okay, so let's think about it. So there is clearly a shift, right? There is a stretch and a shift. Okay, so that's what we have figured out. There is a horizontal shift. A horizontal shift has occurred. So if I think about it, okay. So it looks like we have, so we have this curve, right? If I multiply this curve by 2, so if I consider 2f of x, 2f of x, let me draw it here, is going to look something like this. This is 2f of x. And if you think about it, the blue graph that we're looking at is just a translation of 2f of x. And it's a translation by the vector 1, comma 1. Right? You have shifted right by 1 unit and up by 1 unit. So we want to shift 2f of x by 1, comma 1. So f of x, so it's basically, it's 2 f of x minus 1 plus 1. So that is going to be your solution. So it's the graph of 2f of x, and we need to check the order to confirm whether it actually works or not. So if I write it like this, right? So let's first sort of look at the shift. If I shift by 1 unit to the right? If I do the inside first, then I'm going to get the red curve. Okay, now once I get the red curve, I need to stretch. So if I stretch, I'm going to get the light blue curve. And now if I think about it, if I shift the light blue curve 1 unit up, then I get my target curve. Okay, so this order works. So I just looked at the graph and I sort of guessed the transformations, but I need to confirm whether when I do it in the appropriate order that it actually gives me my final curve, which is just. So this is going to be the solution here. So we're done with question 2. All right. 3. Given that y is equal to x squared and the image of the curve after each of... Find the image of the curve. So basically find the curve. So we are stretching in the y direction but with a factor of 3 followed by a translation by the vector 1. Okay. So we have y is equal to x squared. Doing stretch first basically means I have 3f of x, right? 3x squared. And then we need to translate by the vector this. So that is 3. And then when you do the translation, you get 3x minus 1 squared. So that is going to be your answer. This is your answer to A. So it says a translation by the vector this, followed by a stretch in the y direction with the factor 4. So you have f of x is equal to x squared. A translation is just this, right? X minus 1 cubed. And then you're stretching by a factor of 3. So 3x minus 1 squared. So whether you translate first and do the stretch in the y direction, so whether you do a horizontal translation first and do the stretch in the y direction, or whether you do the stretch in the y direction and then do the horizontal translation first, the order does not matter. That is what this question is asking you. All right. Find the equation of the image of the curve after each of the following combinations of transformations, and in each case, sketch the graph of the resulting curve. All right. So we have this, a stretch in the x direction with a factor of 2, right? That means I have x squared. Now I need to multiply by my x by half, right? Then I get a factor of 2. So half x squared. So which is 1 over 4 x squared. And then, so I have stretched by a factor of 2 means, stretching in the x direction with a factor of 2 means multiplying my x by half, right? 1 over b by half. And then that is equal to 1 over 4 x squared, followed by a translation by the vector this. So x minus 5 squared. That is going to be my solution. A translation by the vector, so I have x squared, translation by the vector gives me x minus 5 squared, followed by a stretch in the x direction with the factor of 2. So that means I multiply by x by a factor of 1 over half. So if you work it out, these two expressions are not the same. That means the order matters here. The order is going to matter here. So if you draw the curve, so let me bring this out here. So x squared is, let me just draw it in blue, looks something like this. All right. A stretch in the x direction. So this tells me I translate first by, okay, for A, I translate first by 5 units to the right, and then I multiply by 1 over 4. Okay, so for A, I translate by 5 units to the right, and then I multiply the output by 1 over 4. So I'm going to get something like this if you evaluate it out. So the point 2 gets mapped to 2 plus 5 is 7, so somewhere here. And 9 times 1 over 4 is going to be like 0.25 times 9 is 2.25. Somewhere here. So this is going to be the graph to A. Something like this. So as you can see, it's actually wider than your blue graph, right? And let's do B. I need to stretch, I need to first translate by 5 units. So it goes, if I translate first by 5 units, then my graph is just going to look something like the dark blue curve that I'm going to draw. Okay, so just translating by 5 units is going to give me my dark blue curve. And then I need to do a horizontal stretch by 1 over 1 by 2. So I multiply all my x coordinates by 2. So actually, I'm going to get the orange curve. So 5 becomes 10. My output does not change, right? 4 becomes 8. 6 becomes 12. And then 3 is going to become 6. Yeah, 3 is going to become 6. So I'm going to get the orange curve for B, something like this. So yeah, you can see that they're not the curve. So the same curve. So the order matters is basically what we're going for in this question. All right, so they're not going to be the same curve if you draw it out. All right, question 5. Given that this is given, find the image, basically find the equation. All right. So a translation. So we first want to translate. So we have f of x is equal to x squared plus 1. You do the translation. So that changes it to x plus 5, right? Oh, sorry. That's a vertical shift. Okay. So you're going to get x squared plus 1 minus 5. So which is x squared minus 4. And then a stretch parallel to the y-axis by a stretch factor of 2. So you just want to multiply by 2 of whatever expression you have. So 2x squared minus 8. That is going to be your stretch final solution, right? All right. And B is a translation by this. So fx is x squared plus 1. A translation is x minus 2. So if you're shifting to the right, it's x minus 2 squared plus 1, followed by a reflection in the x-axis. So a reflection in the x-axis basically means you're multiplying by a minus sign in front of this expression. So basically you're taking minus f of x, right? So that gives you minus x minus 2 squared minus 1. And actually, let's expand this out. So x minus 2 squared is x squared minus 4x plus 4 minus 1, right? I have minus x squared plus 4x minus 4 minus 1 is minus 5. That is going to be your solution to B. And we are done. 6. So the graph of y is equal to g of x is reflected in the y-axis and then stretched with a stretch factor of 2 parallel to the y-axis. Okay. Write down the equation of the resulting graph. So I have g of x, and then it's reflected in the y-axis. That means g of minus x, right? Reflected in the y-axis, done. And then stretched with a stretch factor of 2 parallel to the y-axis. So that means 2g of minus x. That is what they want. All right. The graph of f of x is translated by the vector. Okay, so we have f of x. Let's do the translation. F of x minus 2, that does the translation by 2 units. And then minus 3 does the translation by 3 units down. And then reflected in the x-axis. So if it's reflected in the x-axis, that means minus of this whole expression. So finally, that gives you minus f of x minus 2 plus 3, which is 3 minus f of x minus 2. All right, so we're done with 6. So this is your answer, 3 minus f of x minus 2. Question 7. Determine the sequence of transformations that maps y is equal to f of x to each of the following functions. All right, so we want to do, so remember the sequence that I gave you? That is going to be your answer. So you will have a vertical stretch by a factor of half for A. This is for A. And then part 2, you have a vertical translation. So instead of writing it like this, the textbook prefers you to write it as a vertical stretch parallel to the y-axis with a stretch factor of half, and then vertical translation by the vector 0, comma 3. So that is your answer. So for B, I'll write it in the proper way, right? So 1, you have a reflection. It has the same vertical. So you have a reflection of f of x over the x-axis. And then you have a translation by the translation vector 0, comma 2. So that is going to be your solution to B, 7b. So reflection of f of x over the x-axis, translation by the vector 0, comma 2. For C, now this is the one I told you about. So if you factor out a 2, then you want to do the stretch first. Otherwise, you want to do the translation first. So for C, I prefer to do the translation first, x minus 6. So you have a horizontal translation by the translation vector minus 6. Basically, x minus a means a comma 0, right? 6 comma 0. And then you have a horizontal stretch parallel. So just want to use the sentences I gave you in the previous video. To the x-axis by a factor. So if you have 2, then it's going to be 1 over b, right? 1 over bx means 1 over b is the factor. All right, by a factor of 1 over 2. That is going to be the order. And finally, D. You want to do the vertical stretch first, right? So we have a vertical stretch parallel to the y-axis by a factor 2, and then followed by a vertical translation. So I'm too lazy to write the whole sentence. By the vector 0, comma minus 8, because you have minus 8. And that is it. That is how you do 7. And we're done. Okay, this is the same question. Determine the sequence of transformations that maps to this. So 1 is translation, right? So you look here, you want to start with the translation. Translation by minus 5 comma 0. And 2 is a vertical stretch parallel to the y-axis, by half. That is it. By a factor half. All right. So you just follow the inside out procedure. For this, first start with the inside. So you have a translation by minus 1 comma 0, right? If you have plus, then it's minus 1 inside the translation vector. You have a stretch. You have a vertical stretch parallel to the y-axis by a factor minus 1/2, or you can say reflection. So another way to write this is to break it down. So you have a stretch, you have a vertical stretch parallel to the y-axis by 1/2. You have a reflection. So you do the stretch first and then you reflect over the x-axis. And then finally you do the shift. So translation by 0, comma 2. 0, comma minus 2. And that is going to be your solution. All right, so we're done with A and B. So let me just quickly erase it so we can do C. All right. So this is your base curve. For C1, you have a horizontal translation. Start from the inside by 3, comma 0, right? Then you have a vertical stretch parallel to the y-axis by a factor 2. You have a reflection over x-axis. And then finally you have a translation, vertical translation by 0, comma 4. All right, so we're done. Question 9. Given that f of x is square root of x, write down the equation of the image of f of x after. Okay, so we're given the transformations we want to write. So we have f of x is root x. It says reflection in the x-axis. So that gives you minus f of x, minus root x. Followed by translation, 0, 3. So that is minus root x plus 3, right? You add to the y coordinate. Followed by a translation, 1, comma 0. So that is minus x minus 1 plus 3, right? You change, you write it x, instead of x now it becomes x minus 1, followed by a stretch parallel to the x-axis with a stretch factor of 2. So that changes it to half, right? Stretch factor of 2 means I have to multiply my x by half. It's minus 1 plus 3. All right. So that should be your answer to A. You have y is equal to minus square root of half x minus 1 plus 3. Yeah. All right. So this is your solution. For B, we start with square root of x again. It says translation by 0, comma 3. So that is square root x plus 3. Followed by a stretch parallel to the x-axis with a stretch factor of 2. That is square root of half x plus 3. Followed by a reflection in the x-axis. Reflection in the x-axis means you multiply a minus sign in front of everything. So you have minus square root of half x plus 3. And if you equate it, you get minus square root of half x plus 3. Minus 3, right? Because you distribute the minus sign inside. Followed by a translation 1, comma 0. So finally you have half. You have to do the translation to x. So x minus 1 minus 3. So you have minus half x minus half minus 3. That is going to be your solution. Or actually, you don't need to simplify this. You can just write it like this. This is going to be your final solution. When you do the final transformation, this is going to be your expression. And we're done with 9. All right. Question 10. Given g of x is equal to x squared, write down the equation. Okay, basically the same question. Translation by, okay, so you start with x squared, you translate, so that means x plus 4 squared, right? If you translate by this vector, followed by a reflection in the y-axis. So that means minus x plus 4 squared. You have to change the sign of the x part, right? If you're reflecting over the y-axis, done, done. Followed by a translation this. So that means minus x plus 4 squared plus 2, the entire expression plus 2, because you're adding to the y coordinate, adding to the output, followed by a stretch parallel to the y-axis with a stretch factor of 3. So that means you just want to multiply everything by 3. So after every step, this is f of x. Imagine this is g of x. This is h of x. And then think you're applying the transformation to the final function. So if this is my function r of x, then stretching parallel to the y-axis is just 3r of x. So 3 times r of x is this expression. So it's 3 minus x plus 4 squared plus 6. That is going to be my answer. So the textbook writes it as 4 minus x squared plus 6. It's the same thing. All right, we're done with A and B. We start with x squared. It says a stretch parallel to the y-axis with a stretch factor of 3. That is 3x squared, followed by its translation this, 3x squared plus 2, followed by a reflection in the y-axis. A reflection in the y-axis means you want to change the sign. So this is a symmetrical graph, right? So 3 minus x squared plus 2 is still 3x squared plus 2, followed by reflection of that, followed by this translation. So 3x plus 4 squared plus 2. So that is your answer for B. And we're done. And finally, 11. Find 2 different ways of describing the combination transformation that maps this curve onto this thing and sketch the graphs. So I am not gonna, okay, I'll try to sketch the graph actually. So we have square root of x, and that is being mapped to minus x minus 2. We can follow our standard way of doing this. So this starts with a translation. So let's call this f of x. Of f of x by the vector, so minus 2 is just 2 comma 0, right? So we're doing the usual order, based on the usual order I gave you. And then that is going to be a reflection. So minus x implies a reflection over the y-axis. So that is one way of doing. That is the first order. The second order is the one I told you, is I can factor out a negative sign. And if I factor out this minus 1, I can factor out any factor. So if it's 2, I can factor out a 2. If it's 3, then I need to do the stretch or reflection first. So I can do a reflection over y-axis, right? And then I can do a translation. Now instead of x minus 2, it's x plus 2. Translation by the vector is going to be minus 2 comma 0. All right, so that is the two ways of doing this. And the graph, so the graph of square root of x looks something like this. Something like this. So this is f of x. And basically, if you follow the order, they're both gonna map to the same graph. We are gonna get, so first 2 units, a translation by 2 comma 0 is gonna give me this curve. 1, 2, 3, 4. So I get the green curve. Sorry. Okay. Okay. Supposed to get the green curve, and then now I have to reflect it over the y-axis. All right. So I get something like this. So it's not going to grow, at least on this scale, as fast as the pink curve. Oops, that's too much. So just want to check the outputs here. Please, something like this. That is going to be g of x. This graph. And we're done with this topic. All right, so we're going to start calculus from the next video onwards.